Today my topic is development of silica reinforced liquid silicon rubber composites for advanced tire applications. Today there are many metals are used to design and develop the tire using different technologies. But now ceramic reinforcement in the rubber materials, silicon rubber materials, is a very challenge to improve the relevant parameters in industry. Myself is Dr. Samaya, Professor Center for Metals and Manufacturing, Department of Mechanical Engineering, SR University, Warangal, and also founder of Sales Labs. Tire material challenges. Here is infographic, that is market trends for sustainable tire materials. Trade-off between traction, wear, rolling resistance, because lot of the certifications are required. Government is not given just like because the human life is depends on the vehicle. So a lot of procedure is there to approve the material to use as a tire, to design as a tire material. And heat buildup, durability issues in the high-speed tires. Growing demand for eco-friendly elastomers. That's what in the vehicle, the speed limit is designed for each and every vehicle depends on the capacity. The capacity is designed based on the tire material. That's the reason durability issues, heat buildup, heat resistance meters and all. And here is the properties are in terms of elasticity, thermal conductivity, abrasion resistance, rolling resistance, and fatigue life. For the natural rubber is and SBR, EPDM, conventional silica, filled rubber, and proposed LSR composite. Dear friends, this is I have developed the material of the proposed LSR composite in the Center for Metals and Manufacturing with the support of Study Electric Labs Private Limited. So the elasticity is very high. Thermal conductivity is also very high because 42% is improved, and abrasion resistance is high, that is 38% is improved, and rolling resistance is very low, and the fatigue life is high, is increased more than up to 50%. For advanced polymers, yes, these advanced polymers we can design for tires and advanced tire technology. The limitations in hydrocarbon rubbers, poor thermal management, chemical instability in harsh conditions, the opportunity for liquid silicon rubber as a thermally stable and flexible base. So these all limitations. If we overcome this, yes, definitely that material can be used for designing the tire material. LSR is preferred. My question is, or industry question is, why LSR is used? Liquid silicon rubber is designed for the tire material. Yes, excellent thermal and oxidation stability. Wide temperature range from minus 60 degrees centigrade to 250 degrees centigrade temperature resistance is required for the tire because it is moving with a high velocity. Certainly, the fatigue and friction is generated between the road and tire. That should be resistance is given to that material, and excellent fatigue resistance, intrinsic flexibility, and low hysteresis. So that you see the diagram very clear. That is the fused silica reinforced liquid silicon rubber, indicating that fused silica reinforcement effectively enhances the mechanical strength of the composite. Dear friends, the reinforcement effect is this support trend clearly indicates that fused silica act as a effective reinforcement filler in the LSR matrix, improving its load-bearing capacity and overall structural integrity. This is a very challenging in the LSR. That's what LSR is preferred industry. Liquid silicon rubber. This is the matrix material which were used, and ceramic fillers are used as a reinforcement. Liquid silicon rubber is flexible, chemical inert, thermally stable up to 300 degrees centigrade, cross-linked by hydrosilation, and excellent dielectric and weather resistance and chemical reaction. And you see the diagram that the electrical vehicle is charged, and the silicon rings are designed by using this material. Innovation in the present study. Concept visual is a synergetic reinforcement using silica plus multifunctional ceramics, that is Al2O3, silicon carbide, and zirconium dioxide. These ceramic fillers are used in addition to the silicon fused silica. You can improve the properties. Silicon coupled fillers are used for strong polymer filler bonding, balanced combination of flexibility, toughness, and heat dissipation. These are the very required, challenging for the tire material, which we require to balance all these properties. And my objectives, which we designed in my laboratory, Center for Metals and Manufacturing, SR University, in support in coordination with the study electrics labs. The objects which we designed here developed silica ceramic reinforced LSR composites. And my second objective is optimize filler dispersion and bonding. And third one is evaluate mechanical, dynamical, and thermal performance. And the fourth one is compare with existing rubber system. These are four objectives which we designed in the laboratory and center to uh, develop the material which we use for the tire. Formulation, yes, the composition of different LSR composite variants. Sample is LSR base is weight portion is zero filler no coupling is not required, but LSR with SiO2 silicon dioxide is a participated silica filler type, and weight is a 10 percentage. Coupling agent is a silane, and LSR Al2O3 alumina is a filler, and LSR silicon carbide is a filler. LSR hybrid is the silicon and the ceramic mix is the filler, and silane is the agent for all the materials, and 10 plus 5 or 10 to 15% is used to develop the material formulations. So the required basic things are thermal stability is one side, and other side is the low durability and low thermal conductivity, and the right side you can see mechanical durability. So for this natural NR is natural rubber, and this is a silicon based rubber, and this is the uh, a different rubber filler reinforced metals were used. The interpretation is here. If you want aerospace grade elastomers is higher thermal stability as well as the mechanical durability. These combination you have to design for the tire material by using the fused silica reinforced liquid silicon rubber. You see the diagram very clear. Natural rubber, the tire which we designed with the natural rubber, styrene butadiene rubber, and butadiene rubber, and EPDM rubber, and also liquid silicon rubber. Dear friends, functional objective flow diagram is conventional tire rubbers, that is NR, SBR, PR, and EPDM. But the limitations are thermal aging, UV and ozone cracking, and chemical attack. And performance gap is these are the performance gaps, but we can increase that performance gaps by using liquid silicon rubber, that is, and reinforced with the fused silica reinforcement, improved stiffness, better fatigue life, and lower heat buildup. So that gives the FS LSR composites. This is our targeted material because of advanced tire applications needs heat temperature inner liners, smart tire sensor encapsulation, run flat support elements, and vibration damping layers. So these are the fundamental basic requirement or flow diagrams for the designing the tire material. Property enhancement radar map. So here is the fused silica reinforced expands performance into high temperature, durability, environmental stability, where conventional tire rubbers are weak. Fused silica reinforced LSR composites are engineered to bridge the performance gap between conventional tire rubbers and high temperature elastomers by delivering superior thermal stability, fatigue resistance, and environmental durability for next generation tire technologies. The reason is here thermal stability as well as the abrasion resistance, chemical strength, and mechanical strength, and also fatigue resistance. This is all accommodated in the one metal is called fused silica reinforced liquid silicon rubber. Technical recommendation is a vehicle type, that is passenger cars, trucks or buses, EV vehicles or motorsports, aircraft ground vehicles, industrial mining vehicles, robotics and armored vehicles. All this is the not full tire is not suitable, but functional layer and insert, that is insert and a recommendation is excellent for the aircraft ground vehicles and excellent for industrial mining vehicles, and also it is excellent for the robotics and armored vehicles also. It is perfect by using this material, and also EV batteries highly suitable by the fused silica reinforced liquid silicon rubber. Chart between the now you see normalized performance, that is a score 0 to 10. Blue color is the FSLSR, and it is the natural rubber SBR and BR, and the green color is silica fused rubber. In almost more than fused silica rubber is a little more than in many cases. That's what we are using fused silica rubber for the thermal stabilities and fatigue resistance, chemical and EV resistance, abrasion resistance, dynamic damping, and cost efficiency. So almost this material is very suitable to design the tire materials. Based analysis, yes, definitely the industry market value and trends. The chart showing market value in USD, uh, the billions, and with the corresponding years labeled numerically for each market, laser market, LSR, heat shield, silicon elastomers across their projected growth period from 2023 to 2035. Dear friends, you can see that is at 11.7 in 2035 is a $11.7 billion market value is there by using these materials. Polymer composites needs in the industry is heavily developed by the USA country, and China is the second place, and Germany is third place, and Japan is fourth place by using the polymer composites in the industry. But in India, is only 12 percentage. It's a very rare, but yes, here this is the gap where we need to focus to increase the polymer composites in India to develop the tire technology materials. For watching my video.